Natural language processing is revolutionizing the way we interact with computers by enabling machines to understand, interpret, and generate human language. So, today we will understand the techniques that form the backbone of NLP architectures, including word embeddings, word sense disambiguation, topic modeling, and others. So, let's get started. First is the word embedding. Now, this word embedding is a technique which is used in natural language processing to convert human language text into numerical vectors, which allow machine to understand the relation between words. So essentially, it assigns meaningful numeric representation to each word based on their contextual similarities within a corpus, which enable computers to perform operations on those embeddings just as humans do intuitively with word. For example, in the case of Google search, word embedding help the engine provide relevant suggestions to user based on the query keyword. So if someone searches for Italy vacation, the system would suggest related queries like best beaches in Italy because the embeddings of vacation and beaches are semantically close. So this word embedding has revolutionized various industries including e-commerce product recommendation system, customer feedback analysis, sentiment classification, question answering system, and chatbots. So by extracting insights from vast amount of unstructured data, organizations can gain valuable insights, improve decision making processes, and enhance overall business outcomes. Next comes this word sense disambiguation. Now this word sense disambiguation refers to the NLP task aimed at determining the correct meaning or sense of a homonymous word in a given context. So while most people associate a single concept with every occurrence of a particular term, so in reality, some words have multiple meanings or senses depending on the situation. So to illustrate, consider the verb bank, which may refer either to the institution which is handling deposits and withdrawals, that is the financial bank, or it can be the slope besides a body of water, that is the landscape bank. So this disambiguation enables machine to accurately infer intended meanings even when dealing with polysemous words, leading to higher accuracy in downstream applications such as question answering, document classification, and machine translation. So this example of real world adoption of word sense disambiguation is the creation of domain specific terminologies in healthcare or finance where ambiguous vocabulary poses significant challenges due to unique technical jargon and acronyms. So by leveraging word sense disambiguation techniques there, organizations can build more robust and effective communication system, reducing errors and miscommunication which is caused by ambiguity. Then comes this dependency parsing. Now, this dependency parsing is an extension of syntactic parsing, taking a step further to establish relations between the words in sentences instead of just labeling their roles within a tree structure. So, this dependency graphs provide a better representation of semantic relation than traditional phrase structures because they convey directional links between the words, indicating dependencies rather than hierarchies. For instance, the word ran depends on its subject she. Various adjectives modify noun, forming modifier head connection. So this application benefiting from this technique include machine translation, question answering, and text summary generation. An intriguing area of research lies in using dependency parsing to facilitate multilingual learning, which enables NLP system to learn universal linguistic principles and apply them to various languages simultaneously. So aside from academic pursuits, corporations are exploring the potential of dependency parsing to bolster their content management tools by automating tasks like summarizing lengthy documents or highlighting crucial details for report writing purposes. So ultimately, these developments enable people to tackle increasingly complex problems using smart, efficient NLP solutions. Now, next comes syntactic parsing. Now, the syntactic parsing is a process that involves breaking down sentences into smaller constituent parts called parse tree according to grammatical rules. And it is one of the fundamental tasks in natural language processing, essential for understanding the syntax or structure of a sentence. So, the syntactic parsing is particularly critical for applications involving code generation, code completion, or error detection in programming languages, since coding conventions follow strict structural guidelines. So one interesting use case is the automatic conversion of high-level programming languages into lower-level assembly instruction. So here the syntactic parsing will allow compilers to break down the source codes into executable machine instruction, thereby translating abstract algorithms into binary sequences that computer can execute. Another exciting development is the integration of syntactic parsing capabilities into virtual assistant or voice recognition software, which enhance the device capability to correctly interpret spoken commands and respond appropriately. And these examples demonstrate how syntactic parsing contributes significantly to advancing several technologies across different domains. Then comes this part of speech tagging. Now, this part of speech tagging is a core NLP task that assign each word in a sentence to one of many predefined grammatical categories known as part of speech. So, common part of speech labels include noun, pronoun, verb, adverb, conjunctions, adjectives, etc. And the objective here is to understand the function played by individual words in a sentence, which allow NLP system to comprehend the underlying structure of human language. So in practical terms, this part of speech tagging facilitates numerous applications including spell checkers, autocorrectors, text summarizers, and grammar checkers among others. And this businesses also leverage part of speech tagging technology in areas such as sentiment analysis, where identifying emotions or opinions require distinguish between positive, negative, and neutral words. Financial services firms implement POS tagging algorithms to analyze investment reports or news articles, extracting key phrases, entities, and concepts while filtering out irrelevant or redundant material. So overall, this pause taking has become an indispensable component of advanced NLP pipeline, contributing significantly to the growing list of cutting-edge applications driven innovation across industries worldwide. Then comes this contextualized models. Now this contextualized models or the contextual text mining is an advanced form of natural language processing that goes beyond basic sentence structural analysis and takes into account the surrounding context of the word to drive deeper insight. So unlike conventional text mining approaches that focus primarily on identifying key phrases and themes, this contextual text mining aims at capturing richer meanings and interrelations among entities in the text. So in practical terms, imagine a healthcare organization which is seeking to identify patterns and trends associated with patient symptom and diagnosis. So with contextual text mining, it could analyze medical reports to reveal not only individual symptoms but also underlying condition, commodities, risk factors, drug interaction, and treatment recommendation, facilitating more informed decision about diagnosis, prognosis, and therapy selection. So this technology has numerous other use cases spanning finance, legal, media, and many other sectors, which is empowering companies to leverage structured and unstructured data resources alike, generate new insights, and unlock unprecedented business value. Next comes the topic modeling. Now, this topic modeling is another powerful technique employed in natural language processing, and its primary goal is to discover hidden topics or themes which are present in large volume of text data without any prior knowledge of those topics. So this approach allows researchers and businesses to efficiently organize, summarize, and interpret complex information set, making them easier to navigate and comprehend. A typical scenario where topic modeling comes into play is online retail product categorization. So by analyzing customer review, product descriptions, and user behavior, topic models can automatically classify items into specific categories based on shared linguistic features, thus simplifying browsing experiences and improving recommendation engines. So additionally, financial institutions utilize this topic modeling to monitor news articles, regulatory documents, social media chatter, and market updates for emerging risk and opportunities, which is helping them stay ahead of the curve and make informed strategic decisions. Then comes this tokenization. Now, this tokenization is a critical initial stage in NLP pipeline architecture that breaks down input text into smaller meaningful unit, typically referred to as token. So each token represents a separate entity in plain English, be it a word, punctuation mark, number, stop word, or special character. So this tokenization helps prepare raw data for subsequent stages of NLP modeling, making it easier to process and analyze large volume of unstructured text. And this real life uses of tokenization cover a wide range of applications spanning search engines, chatbot, recommendation engine, and information retrieval system. For example, e-commerce businesses utilize this tokenized product description to help shoppers discover relevant items based on keyword features of brands. So the social media platform employ tokenization techniques to categorize user posts, comment and messages, classifying them based on topic, sentiment or themes, thus improving overall user experience. Furthermore, medical practitioners rely on tokenization to manage patient records, streamlining clinical documents, workflows through automated extraction of structured data points such as symptoms, diagnosis, medication, allergies, etc., thereby enhancing diagnosis precision and care quality. And these examples vividly depict how tokenization forms the bedrock of modern NLP architectures, empowering developers to deliver increasingly sophisticated AI ML models for diverse industry needs. Thank you.